Evaluate the indefinite integral. Illustrate and then check that your answer is reasonable by graphing both the function and its antiderivative. So here's the integral. The integral we have is x times the quantity x squared minus 1 to the third power times dx. So the first thing we're going to do is do our u substitution. So we're going to let u equal x squared minus 1. And then we're going to take the derivative of both sides with respect to x. So we have du, derivative of x squared is going to give us 2x dx. And so we want to be able to substitute that back in here, so we need to divide both sides by 2. So we end up getting 1/2 du, which is equal to x dx. Okay, so now let's go ahead and then do our substitution, writing our original question. So let's go ahead and do that. So we have x squared minus 1 cubed times x dx. Now we're going to put in our substitution, so we know that x squared minus 1 is u to the third power times 1/2 du, since that's what represents x dx. So now we're going to factor out the 1/2 and then integrate u cubed du. Okay, now we got to take the antiderivative. So the antiderivative of u cubed is u to the third 3 plus 1 over 3 plus 1 plus c. Okay, so now we want to be able to then add. So we have u to the fourth over 4, which is 4 over 1 plus c. And then we're going to multiply that by the reciprocal of the denominator of 4 over 1, which is 1/4 times u to the fourth plus c. So 1/2 times 1/4 is 1/8. We're going to substitute back into what u is, which is x squared minus 1 to the fourth power plus c. So therefore, there is our result. Okay, now the next question is, they want us to be able to illustrate and check that your answer is reasonable by graphing both the function and its antiderivative. So if we come into Desmos, we're going to first graph the function, which is x times x squared minus 1 to the third power, which is the one that's in red. So there is that function. And then we have the one in blue, which is when we take and evaluate the integral, and that gives us 1/8 times x squared minus 1 to the fourth power. And therefore, that is the one that's in blue. So let's take a look at that graph and then decide what's happening. So if you take a look, we can see that where f is positive, okay, meaning in this case here, negative, f is increasing, okay? Where the interval changes from negative to positive, meaning positive to negative, then f has a local minimum, okay? So therefore it has a local minimum, which in this case is a maximum. So again, we're just taking a look and viewing the graph to see exactly what is happening there.